What's good, everyone? In today's video, we're going to be talking about building supervisor agents with LangGraph, which is a pretty popular open source framework that was built by the same team that built LangChain and that whole ecosystem. And this is going to fit into the series, right, where we were talking about memory. And this might sound like a bit of a tangent, but the idea at least is take this sample, start building a bit of a realistic kind of use case that you might see in the real world, and then expand upon this in the next video and add the concepts that we talked about in terms of memory design and using Lakebase as a memory store. So if you're wondering why there's a Notion page up front here, I've gotten once again some pretty constructive and also fair feedback that my handwriting is not always the best. So what I wanted to do for any of you that are struggling with reading it is from now on, I'll be attaching a Notion page down below in the description. If you can't really kind of follow along with what I'm writing out and you just want a bit more of a proper kind of clean-cut way of reading and understanding everything, this contains all the kind of core concepts and stuff that we'll talk about. Obviously, it might not cover every single thing or topic that I state, but it will give you a nice clean overview that you can kind of walk away from this video with. So I hope that helps those that are kind of struggling with my writing, and my apologies for that again. But with that being said, not to scare people into this, I'm going to share my whiteboard and we're going to kind of talk about the topic today, and then we'll lay the grounds for the next video in the series, which will also be out this week. So if we come here into the whiteboard itself, we'll see for building supervisor agents with LangGraph, there's a few topics that I wanted to talk about first. What is LangChain versus LangGraph? This is a bit of a confusing point for those of you that are new to this ecosystem, and there's so much vocab and terminology that's changing nowadays that I just wanted to explain this. So LangChain versus LangGraph, and what exactly is our supervisor agent? And this is a very common workflow that we've seen. We've built some use cases on this channel before using managed options on Databricks, but you also see this is a common kind of agentic architecture or topology that is pretty frequent as well. So we'll talk about the supervisor agent. We'll specifically talk about our use case in terms of what are we implementing today. It's a bit of a weather and a weather and a finance planner that will help you kind of automate some trips, which is a popular multi-agent use case that you see. Obviously, it's just a prototype, so you're going to have to expand on it a little. And then 3, we'll finally get hands-on, and by that, I mean we'll inspect some of the code, see a basic kind of Streamlit app that I built, a UI to showcase some of this functionality. But the main takeaway, once again, is right for next steps, we really want to expand on this and integrate Lakebase and memory, some of those key theoretical concepts we talked about in the previous videos in this series, and I'll link those down below as well if you're interested in those parts right here. Cool. So first things first, right? In terms of LangChain versus LangGraph, the reason I want to clarify this is there's billions of frameworks at this point, and it's kind of hard or a little overwhelming if you're new to this world in terms of what to use where. So I just wanted to maybe help you understand a little more in terms of what each of these frameworks achieves. So LangChain is the one that first kind of burst into popularity or onto the scene a few years ago. This is very good if you're building simple prototypes that often have probably a single agent, and then minimal tools. There's not really much complex logic or orchestration happening here. It's just a simple kind of agentic loop that became so popular and is still used, right? That React loop that we're talking about, where you have your different tools, the agent reasons and decides which tool to use. Now, LangChain became popular because it was also model provider agnostic. So if you're using platforms such as, right, like Databricks foundation model APIs, maybe something like Amazon Bedrock, or maybe the OpenAI API directly, it gave constructs ahead of time for all these different model providers. And it really laid the kind of core foundation that we see behind a lot of different agentic frameworks such as Strands, Google ADK that have emerged. And it also provides some kind of pre-built constructs for things such as RAG with different retrievers and different kind of open source tooling there. So open source wise, LangChain is great in terms of integrating with a lot of different ecosystems and platforms. Now, where LangChain falls a little short and where we need something like LangGraph, and this is where it evolved from that same team that built LangChain, right, is with LangGraph, when you have more complex workflows, because in reality, we won't ever have in most real world scenarios, right? We won't have just a singular agent that has hundreds or thousands of tools. That quickly becomes inefficient, and it's hard to kind of pinpoint where the failure might be. Maybe it's a specific tool that is causing the issue. But it's very, very difficult when you have a singular agent that is handling all of that. So more and more common became multi-agent workflows, where you can also have agentic communication. So you will have different agents talking with each other. There might be some conditionality logic in terms of these agents. Maybe in this scenario, execute agent A, or maybe in this scenario, execute agent B. So you can think of things like maybe even a simple if statement if you're trying to think of some sort of pseudocode, where like if this condition is met, for example, execute agent A, and then with agent A's output, take that and feed it into something like agent B. And then maybe on the edge case that this is not met, go ahead and execute agent C. So there's many, many different topologies and kind of customization layers here that you can think of. And that's where LangGraph was built. And the idea of a graph comes from, you have all these different nodes, right? These nodes, which can be specific agents or conditions or tools that you can define. So it becomes much more of a custom type graph workflow where you have more control as a developer in terms of what agents are talking with each other. What's the execution workflow that we're defining? So that's where the word graph really comes from, where you have much more of this topology that you define. So this becomes a lot more similar to traditional kind of backend systems, where in traditional software engineering, right, you would design the control flow. You would design the kind of execution flow and you could test it. Now there's still a layer of the agent being autonomous here because it needs to decide what tool to execute when, and it needs to reason depending on the input. So it's not as like statically typed as traditional backend systems. But with LangGraph, we get some more control back to the developer, and this makes it a little easier to trust agentic systems because we have a little more control over the execution. And you can kind of really add some of the same system designs best practices you see in software engineering here in terms of being able to control this and scale this system. So that's why we use LangGraph today, right? So when we talk about a supervisor architecture, this is one of the most popular multi-agent kind of workflows that you'll see. Some people call it a router. Some people might say they're two different things. The main idea for me here is I have a main agent that synthesizes the output of all the different kind of sub-agents and stuff. Once again, I'm not the best with the terminology there. But here we have a central agent, and this is kind of our router or decision maker, and it has multiple different sub-agents, right, that will have their own kind of tools that they expose. And this becomes much easier to debug, right, than a singular agent having hundreds of different tools. Because once again, this is not really best practice or clean. Let's say each of those sub-agents achieves something very, very different, having different tools with very different descriptions, or in some cases where they're very similar descriptions, it really can confuse a singular agent. So here we kind of decouple everything, and we see some that kind of best practices for the system design with an agent as well. And this will help us more easily pinpoint the issue. Maybe this sub-agent is running into rate limiting issues with one of its tools. I can more easily isolate this, trace it, and understand where exactly my bottlenecks are. So supervisor architecture is very, very popular, and it's something that you see. Now, there's also managed options for supervisor. There's the managed supervisor that is provided by Databricks, for example, in the Databricks ecosystem that we've talked about. And here you can simply plug in your different tools, which might be other Databricks objects, right? So these can be UC functions. These can be maybe model serving endpoints that you want to expose. And they can also be maybe, like other agents such as a knowledge assistant agent if you're in the Databricks ecosystem. But sometimes you want to have your own agentic framework where you control the execution flow and you control kind of the setup of it itself. And that's where using something like LangGraph and hosting it on something like Databricks apps with that scale is what we'll see in the next video, and when you integrate it with something like Lakebase for memory. So here with the supervisor architecture, right, for our use case, we have a mock trip planner agent. And this trip planner agent has two sub-agents. One is weather. Maybe I want to see what the weather's like in the location that I'm planning. And then the other is a bit of a finance planner. And through these, we expose different tools, maybe, for example, such as the forecast. And these are some public APIs that I just found online with the help of Claude right there. And maybe for finance, we have things like a currency conversion. There's basically a few tools that are exposed that are APIs that we programmatically interact with through Python. And here, essentially, right, with LangGraph, we build out this execution flow of where, hey, This is our kind of central agent. And then here we have our different sub-agents that are working together. Now, another key thing LangGraph has that LangChain doesn't, and I should have probably emphasized this here too when we were talking about this, and you'll notice this in the kind of Notion page as well, is state. And the reason for this is, right, let's say our trip planner gets an input that comes in, and then it understands, okay, I should route this to my weather agent, but then that weather agent's output, it also requires to interface with the finance agent. Both agents are required. How do we keep track of what agents were executed, what tools were used? Because we need that information to be passed upon through the entire execution flow. So for a state, we need to be able to track all actions because this is a shared communication system. And in a shared communication system, we need to have a central state. And that's another object basically that LangGraph provides, where with this central state, all of our nodes are constantly updating that execution flow here and reading and writing from the shared state. So we will notice that in our setup today, for any single turn, as soon as an input comes in, right, that state needs to be updated, that object for our multi-agent system to execute as expected. And later on, right, when we talked about short-term and long-term memory, those same concepts build upon this. So when we talked about, for example, a check pointer for our short-term memory across a whole conversation with multiple turns, maybe, right? This check pointer is taking constant, basically, you can think of it as snapshots of this state. So you might have state for a single turn, which is a single inference or an input to the agent or your agentic system. But when you have multiple turns and you're building upon this, you need something like a check pointer that enforces that short-term memory for that entire conversation. And that does that by taking snapshots of this state object, basically. So that is getting a little ahead. We'll talk about that more in the next video too. But that at a high level, right, is essentially what's happening here. We have this multi-agent system that LangGraph enforces, and it exposes these different primitives and constructs that we basically need to build out this system. So with that being said, let's hop into the code directly, and hopefully this will make a little more sense too when we do that. And like I said, this Notion page is there, and a lot of the same concepts that we just talked about are there as well. And here, neatly, right, if you want an idea of the architecture, and this is in the GitHub README too, we have our Streamlit UI that we've kind of started up here. Very simple, just a Python library for building quick mock UIs and frameworks that I've used for the last few years. And here we have our supervisor with our custom state graph, which is once again what's enforcing that communication or allowing for that communication between your different nodes. And then we have two subnodes basically, which is the weather subagent, our finance subagent, and within this weather subagent, we expose three different tools: get weather, get forecast, get air quality. Same for finance, three other kind of sub tools here. So you can assume we can ask sample questions, and we'll take a few of these directly, where in certain cases, only the weather subagent should be invoked. Certain cases, only the finance subagent should be invoked. Certain cases, both are invoked, and you can see some of that parallelization is being enforced by LangGraph. So if we come here to the code itself, and I actually have my IDE up, so we can come in here so it's a little cleaner, we will see there's a few different files here. The app.py and main.py, you don't need to worry about too much. The app is just the Streamlit UI. That's not really the focus of today's video. And then we have the main.py, which is just helping us kind of parse our different tool calls and our text that we have here. Now, if we come here, we will notice we have our graph, which brings everything together and builds our agent. But for this graph, right, when we're building this, there's two methods right here. We're building our weather agent and we're building our finance agent. For my LLM that's powering everything here, basically I'm just using the foundation model APIs via Databricks, and I'm pulling down GPT-5.5. You can use whatever LLM provider you're comfortable with here or whatever you're using currently. I then have these two tools, but these two tools are kind of abstracted out right here. So if I go to my sub-agents, and we'll see for each of these sub-agents, basically, I have a system prompt. For my weather prompt, I'm basically saying you're a weather specialist. You can look up kind of the conditions in a city. So if I say, what's the weather like in Paris today? And things of that sort, it has the tools basically with the logic that will help us answer that question. And you can see that in this tools.py. And you don't need to really understand the APIs here, but the main essence is it's implementing everything we have in those system prompts for those sub-agents. We'll see we have the get weather tool. We're interfacing with an API there, get forecast, get air quality, and then for the finance sub-agents, converting currency, comparing currencies, getting a historical rate. These are basically the 6 different kind of backend functions that we have that are interfacing with our different APIs or tools. And you can obviously expose them as needed. Maybe you have an MCP server or something like more standard that you want to work with there. Now, if we come to the sub-agents, we just capture all those together in this array for the weather tools, array for the finance tools, and we basically are using the same foundation model for each of the sub-agents and the main LLM itself. Now, that's where you might want to make a decision for certain sub-agents or certain queries where you think you don't need as intelligent or more importantly, as expensive of a model. You can use a smaller LLM. So model routing becomes very, very popular and common where for more complex tasks, you use something like GPT-5.5 or something that's more of the latest and greatest. And for simpler kind of subtasks, you can kind of benchmark and test smaller and more cheap kind of models that still get you the quality that you need. So that's all I'm doing here. I'm defining my sub-agents prompts, and these are nodes, once again, in that graph or execution flow that we're talking about. And we can see this here when we're building our agent. So here we have our call weather sub-agent. We're simply going to take our system prompt and those tools that we defined there, and same here. So technically, we're exposing the sub-agents as tools, not to get confused, but it's the main kind of essence or logic within this for these right here. And then for the sub-agent tools, we have that all defined, which we had earlier for the call weather sub-agent method that we have here. And we basically build this out. And now here, right, within this return method, after we've binded the tools to our supervisor LLM, which are these sub-agent tools, which is just kind of like a chain as you can think of, we define our graph and we have the different nodes that we were talking about. We have our supervisor node, and you can define things like retry policies. So this is the same kind of system design that we talked about there. And then here we add a node called sub-agents, and these sub-agents basically point towards our two sub-agents that we've defined and their corresponding tools that we're working with basically. And then we can add edges. There's also cases where you might have conditional edges, where maybe you have some custom function where you should only execute something if, for example, this value is met or whatever other logic you have there. And we then compile this graph. So this is our final kind of agentic system neatly captured into this singular graph object. Now, if I start up my Streamlit app right here, that's the different code that I have exposed here essentially. For this graph.py, we can come to the UI. We have this mock trip helper supervisor, and I sent some queries. So for example, if I ask a query that is not related to either weather or finance, let's say like who is Roger Federer, my favorite prompt as always, this should not invoke any of the sub-agents. And we can see here in real time, the supervisor is writing the query, and you can capture this entire trace basically here. We do that as part of the UI kind of rendering here. So we can see what sub-agents were called, X, Y, and Z from there. And when you're productionizing this, you want to use something like MLflow experiments, use like the managed version, whether you're hosting it yourself or using it on somewhere like Databricks. You can kind of see the entire control execution and flow. Now let's maybe ask a question that will require the use of a tool. What is the weather in Paris today? And this should appropriately hit our weather sub-agent, and that weather sub-agent should use the appropriate tool there as well. So if we see here that execution flow happens, we get our output. I don't know if it's fully accurate. I haven't benchmarked this API itself or tested it for quality or evaluated it for quality, but we can see it does the expected kind of behavior here. And that, in essence, right, you can take other questions. You'll see I have some sample ones here. Once again, this is a prototype, so you can adjust it as you want. So let's say maybe how much is $500 right there. Grab that. You can play with these and you can see use cases where only a single sub-agent's hit, or you can see where both sub-agents are kind of invoked and there's some sort of parallelization happening there essentially. We can see this happens. We see our finance sub-agent was hit. Once again, we're exposing that as a tool or defining that as a tool. And within that, the appropriate tool that was needed to be called there was invoked as expected. So at a high level, our kind of mock trip planner is working as expected. So now, right, this is an introduction to maybe a bit of a realistic use case. How do we expand upon this? Because if I ask this chat a question right there, right, for example, if what was the last question I asked right here, this is not going to have any memory in terms of this because we don't have that in terms of this session ID or this conversation yet, where we're retaining basically all these previous questions we have. So we need to keep appending that state or those snapshots to something like a checkpointer where we have that for our system to retain basically. And then for long term, for things like semantic and episodic or episodic memory, as we were talking about, we need something like a store or like a PostgreSQL engine where we can store things such as user preferences. So if I log in and I'm Ram and I'm planning a trip for London, I don't have to restate that if that was already within your memory, right? And that was already one of our recent conversations. Maybe I have a preference in terms of what type of concurrency I would like to use. Sorry, currency, not concurrency. I keep mixing those words up there. But if I have a preference like that there, none of that is built in or baked in yet. That's where we're going to bring in some of the LangGraph built-in constructs, such as a check pointer and such as a store, and we will see how easily they can integrate with something like Lakebase to enforce those memory designs we have, and we're going to end up with a much more realistic application in terms of giving something that actually has that user personalization and memory retention that we were talking of. That's mainly what I had for today. I hope this video was helpful. If you have any feedback, as always, please leave it down below in the comments. Any questions, just want to help out the best I can there. So that's mainly what I had, and I'll be back with more, and we'll continue and follow up with the topics we talked of. Thank you, everyone.